In this video, I'm going to show you a PID demo using the data acquisition control system. So we're going to control the position of this fan with, the position of this deflector with a handheld fan based on the output voltage from a Hall effect sensor. We've chosen the USB option, which works great for this basic application. Now, I just want to throw in here before we start that if your application needs more predictable and precise timing than what you'd get with USB, you want to look at the PCIe options and look at doing some real-time with that. So let's jump right into LabVIEW, which is our graphical programming language. So we'll start with our block diagram. So first thing I want to do is I want to read the value from my Hall effect sensor. To do that, I'm going to right click, go to Measurement I/O, DAC-MX, and DAC Assistant. So we'll put one of these down, and it'll ask me, what are you doing? So since it's a sensor, we're acquiring the voltage from the sensor. It's an analog input, and it's a voltage. Now I know that it's on analog in channel 0, because that's how I've wired it up over here. You'll notice that it says 6211. If you have any other data acquisition device, it'll show up here, and you can choose the channel in the same way. So we'll click Finish, and it'll ask us a few other things. So the first thing I want to change is I know my Hall effect sensor is going to put out 0 to 10 volts. It's reference single-ended. And I only want one sample, and I want it on demand, so whenever I ask for it. So if I run this, you'll see I get a voltage reading. So that reading is the value coming from my Hall effect sensor. So if I move this slightly, you'll see the voltage increases. If I move it back down, the voltage decreases. So that looks good. It's working well. So we'll click Stop and OK. So now that we have our reading from our Hall effect sensor, next thing we want to do is wire that into a PID VI. So the PID VI we're using, we get to by right-clicking, going to Control Design and Simulation, PID, and then just the basic PID VI. And this value we wire up to our process variable. So the PID control toolkit comes with the PID algorithms. So now we need to wire up other things to the PID VI, so I'm going to right-click, create control for my output range and for the PID gains. And then one last thing we need to do is go into our front panel, and we want a way to be able to change our set point. So I'm going to put down a slider, so right-click, I'm going to drop down this, and it's our set point. So we'll resize that. And then we want a way to be able to see the value of our set point versus the actual value coming from the Hall effect sensor. So I'm going to right click, I'm going to put down a gauge. Make this gauge a little bit bigger so you can see it. And I'm going to add another needle. So one needle is for the set point, one is for the actual value coming from the sensor. We'll change the color so you can distinguish between the two. So there they are. And then I'm going to change the range of both the set point slider and our gauge, because I know the set point is only going to be between these values. It'll make it easier to see my system. Okay, so back to our block diagram. Now we have this set point coming from our front panel. I'm going to wire this up to my PID VI. Make it a little bit easier to see for you guys. So now I want to wire up the set point and the value coming from the DAC Assistant, which is our sensor, to the gauge. Before I do that, I noticed that the value from the sensor jumps around a bit, so I'm going to clean it up using a filter. I'm going to right-click, Signal Processing, use a point-by-point filter, and the probability and statistics, and median works pretty well. So we'll drop this down, And I'm going to wire up this straight to the point by point. I only want 25 points at a time. And then to get both signals, both the set point and my sensor values, I'm going to need to bundle them. So I'm going to right click, select a bundle, I'll wire both of these up. And then I can wire this straight to my gauge. So now the last thing we need to do is we need a way to output a value to our fan. So we're going to do the same thing we did for the sensor. We're going to right click, go to Measurement I/O, DAC MX, and then DAC Assistant. So we'll drop this guy down, and once again it'll ask us those questions. So because we're outputting a value from our USB device, we're going to choose Generate Signal, Analog Out, and Voltage. And for my USB 6211, I've wired it up to Analog Out 0, so AO 0. We'll click Finish, and once again it'll ask us the same thing. So for the output to my fan, it can only take 0 to 5 volts, so we'll change that. And once again, I only want one sample on demand. And that's about it. Nothing else that we need to do. We'll test it real quick, make sure it works. So my fan doesn't really turn on until I give it about, well, we'll give it 2 volts. So I'll hit run. You should see the fan turn on. There it is. And you can easily change these values to test your output before you finish configuring. So we're going to go ahead and turn off the fan, click OK, because that works pretty good. So the last thing we need to do is wire up the output from our PID VI to this DAC Assistant, since we've just configured it. So output to our DAC Assistant. So the way it is now, we're only going to run the VI once, which means that all this code just runs once, and for true PID control loop, we need a loop. So I'm going to right click, I'm going to encase all this in a while loop, and then we need a way to stop the loop at some point, so I'm going to create a stop button. So now we'll go to our front panel. Some last things we need to take care of are our output range. So this is the voltage output values that we're going to send to our fan to control it. So once again, it can only take 5 to 0 volts. And the reason we have to put this in again is because these are the values that the PID VI are outputting. And these default values actually work pretty well for my system, but most of the time you're going to have to go in and tune your system to get these values. So that should be it. So we'll run the VI, and I'll move the set point. So you'll see my set point is the green one, and the red one, I'm sorry, the green needle, and the red needle is the output voltage from the sensor. So it did a pretty good job finding that, and I can move it around a little bit, and you can see it responds to that. It may take a little while to get there, but. And then we're going to go ahead and disturb the system a little bit, and you can see the control response. I think you can hear the fan speeding up. And then it'll take a little while, and it'll read the value of that sensor and slow things down. Yeah, there it goes. So and that's about it. So pretty simple to put together a quick PID control system.